Alright guys, we're back. We're going to set up and do these serrated teeth or saw teeth in this tool holder now. We've got the tool dead on centre and square. All the tool holder square to the table. The first step is going to be 4.5 degrees rotation and then 9 degrees thereon after. And we'll continue the 9 degrees all the way around so we don't have any backlash issues and come back. So that's my rotary table, and with my dividing heads and rotary table I've put stepper drives on here, and I built this little controller back in 2012, 2013, a while ago, on CNC Zone, a guy called Steve Ward, I think with the pseudonym of Knackers or Knackers, put up a hex code and the schematics for this unit. So a matter of downloading the hex code, burning the pick chip, and then doing the schematics and just buying everything off eBay. Made up my own keyboard. It's just a bit of A4 laminated sheet with the numbers and control buttons on it. I did this for it was under $100, so that was really good. Little separate 5-volt power supply coming in to power the electrics inside the box, and I've got a separate 32-volt 2.5 amp power supply coming in to control the or give power to the through the driver to the stepper. And it's a very easy thing to do. So you've got a number of parameters that we can select off this, or a number of modes, so we can jog it in 10 degree, 1 degree, 0.1 degree or 0.01 degree increments. We can select degrees. There's a programming function in there. You can go by divisions if you want to do it that way, or you can go continuous if you want the thing to be continuously driving. So if you're cutting out radiuses, and you've got a setup function there, and you've got up to 5 different programs that you can run on this. So if you've got a dividing head at 90 to 1 and another one at 40 to 1, you can set them up differently and then call that particular program up each time, so it's unique to that particular dividing head. So we're going to select the degrees, which is 3. We're going to select 4.5 degrees to start with, the 4.5. We'll go with that. So we've taken the backlash out. We have the tool on center, as we said. So I'm just going to press the go button on this, and we should get 4.5 degrees, which is there. We'll lock the table off there, and we'll start our cuts. So I'll get this camera set up on my microphone stand, and we'll have a look and see how we go. Alright, we'll get a scratch on that first. It's giving us a nice even scratch. I'll just zero my digi out at that. My x-axis. I'm going to go in 1.88 millimeters. So I'll just take this very easy. Because we're cutting such a wide mouth on this, we're not going to rush this, we're going to take it pretty easy. Just going to slow that down a little bit. Joys of having a variable speed drive. Righto, so we've cut the first one. and just loosen the table off. We'll reset. It's back to 9 degrees. 0, 0, 9, go. Alright, so if we rotate that around now, it's our first 9 degree. I've just pulled the tool back a little bit just to try and reduce the vibration, so I'm going to have to zero that. So I'll do that now without crashing anything. That's fine. Just touching now. Bring it up a little bit. To depth there. Well, that's a lot better. It's a nice finish. I've pull up the table up too. So easy to do when we're focusing on all sorts of other things. Alright, so we'll go around our 9 degrees. Come on back in. Still bang on 0. That's what we want to see. That's the size there. Back it out. Loosen the table off. 9 degrees. And we'll continue on with that. And I'll bring you back when we just cover the last two. Alright, we're cutting the last one. We just started cutting the last one. It's always the last one we're not going to gear tooth. It's going to tell you how even you went. How evenly it didn't go. That's it down to size. Let's have a look. I'll tell you what, that looks absolutely spot on, just looking at it. I'll take it out and we'll clean it up. And we'll see how it all looks. Alright guys, so we've finished this. And in the end it's come up spot on. I can engage that into the male part of the tool holder and I get absolutely no movement. I've got a nice even gap all the way around. Everything's absolutely spot on, as in a gap on the root of the tooth. Everything's nice and even. You can see every flank is engaging beautifully. Nice tight fit. But there's a but. As I said, ended up well. And I did notice this off camera. I got a little bit aggressive with the infeed, and I thought I saw this nudge out just fractionally. I wasn't sure, so I just nipped it up again and it continued around. And you can see how it's ended up. On this end here you can see a small step, and on this end here you can't see a step at all, so it's kicked it out. And I actually measured it, was around about 12 thou is what it had kicked it out. So it's not sheep stations. So what I've done is I've gone around again off camera and just made sure that everything is to depth and just cleaned up everything again to make sure that everything's even. And what I'm going to do to try and fix that little problem is I'm just going to lick this on the milling machine. Just machine a very, very light taper all the way through just to take that little lip out. We'll then square this face here up again to that face, and we'll square the ends up. So aesthetically it's going to look fine. It's not going to affect the way it operates in any way, shape or form, but at least it's going to look right. But hey, who hasn't had something move in a fixture? So easy to do. In hindsight, I should have put a backing block behind here to give it a bit more stability rather than just relying on the two clamps. But geez, hindsight's great, isn't it? We'll get it fixed and we'll get it right, and then we'll move on. Righto guys, we'll get set up to do the holes in this tool post block. Going to drill the holes that allow the bands to fit in, or the cam bands. These are things that overcenter and actually pull this in hard into the female part of the tool post. So we'll drill these out first. I'll also drill the holes for the height adjust mount, and then we'll set that up to cut the slots for the bands to fit in. So I usually don't tend to mark things out. I usually tend to set up a datum when I'm drawing, and then use the digi readout for the positioning. Righto, we're back again. I'll tell you what, it's not too bad off camera. I don't know what you blokes do in your shed for entertainment, but I stick on a bit of the music, a bit of the old retro 70s stuff, bit of the Jam, bit of the very early AC/DC or Pink Floyd. Do a bit of a disco dance between the lathe and the milling machine, a few moves, and a good wife comes in, or the kids, and shake their heads and embarrassed to be seen with you. But hey, look, this is manland. The rules of society don't apply here. We can do what we like. Goodness me. Alright. I've drilled all of our holes, our two holes for our bands. I've drilled and tapped this hole for the height adjuster block that's got to go on here. But I thought I'd bring you back just quickly on some taps that I use and what I do. When you buy a set of the small taps, they always seem to come with the point ground on them. You know, they make great scribers, but very hard to get to the bottom of the hole. So on the plugs, I always grind the tip off. That way you can get at least down close to the bottom, or if you have to, get a full thread down to the bottom. They're also point ground on the ends, which makes it very hard if you want to pick up use a center follower to keep them in line. So I tend to use these little T-handle units, and they've got the center already in them there, so you can always pick that up. Unlike these T-bar handle type ones, when you put them in there, you can't really get an alignment on them. A little bit awkward. So yeah, I tend to use these blokes. And what I do if I've got a lot of these to do, I'll actually put them in my good old Aldi Taurus battery drill, and I can go up to M6 with these and just thread them in with this, and I've never ever broken a tap. I've done down to 3 mils with this, never broken a tap. I've certainly broken taps off using these, but I've never actually broken a tap off using my trusty old battery drill. So alright, so I'll finish tapping that one off. I'll come back and we'll do the setup to cut these bands in, slot these bands in, and once we've got those done, we can go and try it over in the tool post and actually see how it looks. So I'll put a bit of retro music on again, and I'll be back with you soon. Alright guys, we're back again. On my drawing, I've got the slots set up at 15 degrees horizontal plane. So to get that 15 degrees, I use one of these little Wixleys. Well, there's all sorts of little box digital devices you can get, but these are the levels. But I reckon these are absolute rippers. They save so much time. I zero it up on my bed first because my bed is a little bit off to one side, so I zero that off. Then I pop it up on my part. And I set that to 15 degrees. I'll zoom in a little bit. So that's set to 15 degrees. I then take the drill in that I've used for drilling the holes for the band blocks, and I've just used my edge finder on either side just to get the exact centre for my cutter. So we've done that. My drawing that I've put together shows that the slot is 5.5 wide, and look, that's not really critical. It's only to allow the difference in the expansion or the locking of the band and the loosening of the band. There's a little bit of flexure in it, so it's just to allow a little bit of a gap for that flexure to occur. So we've got it to that point, and all we need to do now is slot through. There you go, juice on. Right, 2 mil at a time. So there we go with that. Now I'll just side cut 0.25 of a millimetre on either side to get that at the 5.5. I prefer to use end mills for slotting. I find with the slotters the chips tend to get picked up on the cutting edges and drag through and create those little tiny divots all the way through, and makes a horrible rattling noise when it picks the chips up and drags it through, but for some reason you don't find that happening with end mills. Also with slot drills, I find if I'm drilling a key or slotting a key and your end mill is dead on size, which it shouldn't be, you should always try and side cut. As it comes up to the end, it always tends to do a little bit of a divot off to one side. End mills tend to stay dead true, so I prefer using end mills for cutting keyways and slotting than slot drills. Right, we'll just set that up for a side cut. Hello guys, we're back. It's the next day. I'll kick the camera. It's the next day today. It's pouring down rain outside. It is freezing. I'll tell you what, I reckon there's nothing better than being in your workshop in the middle of winter when it's freezing cold. You've got the pot belly going and you've got a Saturday afternoon to yourself. It's great. I've got to get a life, haven't I? Let's try this into place and we'll see how that all fits up. That locks up beautifully, slides on and off beautifully. Let's try it this way. When I look at that, those serrated teeth are a perfect fit, just looking by eyeball. And that is perfect. Full engagement on all of those. So I might take the camera off and I'll just have a poke down the top there and you can see what I mean. There is one thing I wanted to check though. We had that little mishap when the tool moved and I had to re-square it up again. I'll just try it on one of these holders, which I know are spot on, and we'll lock the both in together. And yeah, that land down there that I want to see is even all the way down. that gap is even. So not very happy with that. We'll bring the camera over and we'll just show you how that sawtooth looks. Alright, let's try this again. I started doing this shot with the tool post and the tool holder engaged, and the rain came down and you couldn't hear a thing on the tin roof. It was just so loud, so it stopped for a moment, so we'll get a shot of this. So try and do this by using one hand. Right, so that'll give you a bit of an idea. That's a perfect engagement onto those sawteeth. And loosen this off just a little bit, and we've got, she rattles and rolls, and it comes off very easily and locks up very well. So I'm really happy with that. Right, the next job we're going to do is I'll make up the height adjuster block, and then we'll cut the slot into this, and we'll be done. Alright, so we'll get set up and we'll get going. A bit of a break in between these rain showers, it's a little bit quieter. Off camera I've milled our block up. So out of that bloom I cut a section 55mm long, and we've machined it down to our sizes, 53 by 23 by 28 high. So now we need to start shaping it out. So this is one that I've done earlier, and the easiest way to go about doing this is first of all to shape out this front face first. So basically mill all the way across down to a thickness of 14, and then come down a little step of 4mm in there. Take that little section there out, and we'll flip him up, and then we'll, down on plan, we'll then slot out those two corners. So that's the plan. We'll get set up and get that underway. I won't spend an awful lot of time filming this because we're really running out of time at the moment, and Emma's probably onto a third glass of wine at the moment, wondering when this guy's going to stop waffling on. So I'll get this set up and we'll get underway, and as I said, we'll come back and have a quick shot with some of the setups. Alright, so we've roughed out with one of the tip cutters, and we bring it to final size with an end mill. Right, I'll come back, we'll take that lip off, then we'll set up with a 10mm end mill, and we'll start shaping out the guts to this. And that's it, we're done with that cut out. So what I'll do now is we'll lay this up on its edge and we'll notch out those corners. And then we'll drill and tap the hole, drill these holes for the fasteners. Alright, we're coming up to the last cuts. This notch out. Just a little bit of a side cut, one more side cut to there. Okay, we're just taking the relief cut in the back of this height adjuster, and it's really only to allow this socket wrench to fit down and do up the square heads. Now I haven't got square heads on these tool holders, they're just socket header cap screws, so it's not really required, but you never know, one day in the future I might make them a bit more authentic and put the proper square headed screws on. But anyway, we'll cut this the way it is on the originals, just to make it look right. Okay, so this is done with a 1/2 inch bullnose cutter, that one. Alright guys, I'll just do a very quick take on this. Cutting 45s, I just use these little countersink tools. They do a great job. They're really good for getting into tight little spots, and they do a nice job. Alright guys, just cutting the slot now. I'm doing it in 3mm step downs, and another 2 cuts and we'll finish this, and I'll just do a little slight side cut just to clean it up. So it's a 3/8 cutter that's in there at the moment. These are one of these cutting sets I bought from one of the Chinese supermarkets, and geez, I tell you what, it takes a fair chip load on it, and it's still cutting beautifully. So we'll get the slot cut in, and we'll drill and tap for our socket header cap screws to hold our tool in place, and we're just about done. I'll show you how I tap these with the drill. My trusty Taurus LD battery drill. Now 6mm is probably the max you can go doing this, but as I said, I've done down to 3mm M3 taps without any issue. There you go, how easy is that? Nice and quick. Alright guys, this is a CR32D14 adapter plate that I remachined up because it was way out of centre. So with these little socket header cap screws that we're going to use for holding our tool bits in place, we need to just take a little bit of a lick off the bottom here, get that down below the root of the thread, so that when it does mushroom out, it's not going to affect us if we need to get these back out of the tool holder. Just take little cuts at a time. I know there's a big overhang on this, but little cuts at a time. There we go. Alright guys, I'll show you one of the final machining operations. Just because I've got one, I'll use it. It's nice to put that ground finish on anything you do, and I certainly make use of it for that reason. And this little unit here is extremely accurate. I'm very happy with this, and it picks up all your little machining mistakes. Like I've done a run on this already, and we're only 0.02 of a millimetre out in parallel on this, so that's not too bad. Gives you a little bit of confidence that your vise and your table and your setups on your mills are well within specification. Done. And that puts a gorgeous finish on that. And I don't only use this for surface grinding, I use it for all sorts of things. particularly dressing up my high-speed steel end mills and slot drills. So very universal little machine. There's lots of little jigs and fixtures you can make to do all sorts of things with these surface grinders. Alright, we'll machine the rest of those edges and Alright guys, we're almost finished. I've made the adjusting screw up off camera. It's a fairly straightforward job. It's just a bit of M5 all thread, bit of 8mm stock I've machined down to 6.5 and then knurled, drilled a 4mm diameter hole up inside it. We've turned the end of the all thread down to a matching diameter, so it's a reasonably close fit up inside, a little bit of Loctite, and on she's gone, and that's made up our screw. It's turned out quite nice. That's the final product. I've made the spacings on these a little bit different, and then I've got some very, very small little boring bars that I use, and I want to make sure that when I use those I've got clamping force all over, and obviously when we use the little tiny boring bars we can clamp that up along the length of those as well. So everything's bolted up, everything's finished. Not much more I can say on it. We'll just take the camera over and we'll show you how it looks in the tool post. Righto, so on she goes, and she locks up really nicely. And we can do the adjusting however we need to and lock it up. And yeah, it fits up beautiful and square. So really happy with that. That's another tool post holder to add to the set. So I've got 1, 2 and 3. So that's 4 altogether that's been made up. Alright guys, we'll call that a wrap. Thank you for Emma for putting on this little competition. It's great exposure for everyone, and really appreciate the time and effort that goes into doing something like this. Unless you've ever done anything like this, you just don't know how much time it actually takes to organise and run. So thank you very much, Emma, and good luck to all the other guys having a go. Alright, see you soon.